Welcome to Brain Vision.
In this problem, we're looking at a distant galaxy that is receding from Earth. So its motion from the center of the galaxy, UG, is moving away from the Earth at a speed of 1.6 times 10 to the 6th meters per second. Now there are 2 points on the edges of the galaxy as it's rotating. Because it's rotating in a counterclockwise direction, these points are moving either towards the Earth or away from the Earth at those points. And so the tangential speed, Vt, is equal to 0.4 times 10 to the 6th meters per second. Now that tangential speed is relative to the center, so when it's moving away from the center, like over here at point A, velocity of A is opposite the direction of the galactic motion. So it's speed of the galaxy minus that tangential velocity. Over here at point B, its velocity, VB, is going to be equal to the velocity of the galaxy plus the tangential velocity. Since they're moving in the same direction, those velocities add up. So this point B is moving more quickly away from the Earth, while point A is moving more slowly away from the Earth. But in any case, their overall motion is still away from the Earth. Now, the other piece of information they've given us is that light emitted from this galaxy has a frequency of 6.2. So frequency of 6.200 times 10 to the 14 hertz. But at points A and B, because of their relative motion, each one of those is going to have a slightly different frequency. And to figure that out, we're just going to use the Doppler equation. I'll write it up here for us. Frequency of observer is equal to frequency of the source times 1 plus the relative velocity between frequency and source. I'm sorry, that should be plus or minus, divided by c. What we're going to see is that when the observer and the source are moving relative to each other, towards each other, then we're going to add their 1 plus the relative velocity. And if they're moving away from each other, as in the case here, we're going to use the minus sign. So this here, we're using the minus sign because each of these is moving away from the Earth. So let's go ahead and figure that out for A. So the frequency observed for A is equal to 6.200 times 10 to the 14 hertz. And sorry, I didn't give myself enough room. Let's try that down here a little bit. Frequency observed A, 6.200 times 10 to the 14 hertz. And then we multiply that by 1 minus, because it's moving away from us, the relative velocity. Well, that's VA, which if we plug in the speed of the galaxy, 10 to the 6th, minus that tangential, 0.4 times 10 to the 6th, then we'll see that this relative velocity is 1.2 times 10 to the 6th meters per second. And divide that by c, the speed of light. 2.9979 times 10 to the 8 meters per second. Now we plug all that into our calculator, and we see that the frequency observed from point A comes out to about 6.175 times 10 to the 14 hertz. Now we can do that exact same thing over here, but for point B. Frequency observed at B is that same emitted frequency, 6.200 times 10 to the 14 hertz, multiplied by 1 minus, because it's moving away from us, minus sign there. And in this case, the velocity at B is 1.6 times 10 to the 6 plus 0.4, moving in the same direction. So those velocities are going to add together. And that gives us 2.0 times 10 to the 6th meters per second. Again, dividing by the speed of light, 2.9979 times 10 to the 8 meters per second. And you get about 6.159 times 10 to the 14 hertz. And that's the frequency observed from point B.